All right, this is Chemistry Podcast 9.1, and we are going to talk about measures of concentration. So the first thing, because we're talking about concentration, means that we're talking about solutions. And solutions are homogeneous mixtures. You should remember that from the very beginning of the year. And a homogeneous mixture that contains two or more substances, and they are called the solute and the solvent. And the solute is what is dissolving. The solvent is what does the dissolving. And solutions may exist as gases. So if you think of all the air around you and all the mixture of gases that are in it, that's actually a solution of gases. There are solutions made of liquids, and an example of that is vinegar. Vinegar is a mixture of water and acetic acid. And then we can also have solutions that are solids, and any of your alloys that are mixtures like steel or brass. Those are actually solutions in the solid form. But the most common ones we see are liquid solutions. Solution concentration, and then concentration, the definition of it is a measure of how much solute is dissolved in a specific amount of solvent or solution. And these are the most common concentration descriptions we can have. When something is more concentrated, it means it has more of the solute dissolved in the solvent. If it's less concentrated, we also refer to it as dilute. It means it has less of the solute in the solution or the solvent. So we're going to talk today about percent by mass, percent by volume, molarity, and molality. Percent by mass is the first concentration calculation we're going to deal with. And when we're talking about percent by mass, we're usually describing a solution that has a solid dissolved into a liquid. And that liquid is normally water. So what we're going to do is we're going to take the mass of the solute, which should be the solid, and divide it by the mass of the solution and then multiply by 100. And here's the question that we're going to answer. I'm going to go to the next page where I have a little more room. It says an aquarium must contain 3.6 grams of sodium chloride per 100 grams of water. What is the percent by mass of sodium chloride in the solution? So the solute is the sodium chloride, and that number is going to go on top. And I want to divide it by the mass of the entire solution. So not just the water, but the water and the sodium chloride. So there's going to be 100 plus the 3.6 grams from the sodium chloride. I do the division, I multiply by 100, and when I do that, I get an answer of 3.47% sodium chloride. That's the percent by mass of sodium chloride in that solution. The other type of percent calculation, I guess, is percent by volume. And percent by volume deals with the solute and the solvent both being liquids. And so we take the volume of the solute. You'll notice that the solute is always on top, divided by the volume of the solution. And the solution is the entire solution, so solute plus solvent. Then we multiply by 100 to make it a percentage. I'm going to go to the next page. It'll have the same question again. It says, what is the percent by volume of ethanol in a solution that contains 35 milliliters of ethanol dissolved in 115 milliliters of water? So the solute is usually the one that's in the smaller amount. In this case, it's the ethanol, and water is normally the solvent. So we put that on top. We want to divide it by the water's milliliters and the 35 from the ethanol. So that's the total solution's volume on the bottom times 100, and when I do that, I end up with 23.3% ethanol. And there's your answer to that problem. So you're going to notice that the solute is always on top, and either the solution or the solvent is always on the bottom in these types of problems. We have some practice problems that we're going to go through, and there are 4 of them. The first practice problem says, what is the percent by mass of sodium bicarbonate in a solution containing 20 grams of sodium bicarbonate dissolved in 600 milliliters of water? Well, the first thing we need to watch out for is this is not in grams, but we know that with water, 1 gram of water is the same as 1 milliliter of water. So if I have 600 milliliters of water, I have 600 grams of water. And I'll be able to use that on the bottom of my calculation when I'm trying to figure out the total mass of the solution. I put the sodium bicarbonate on top because it's the solute. I divide it by the 600 grams from the water plus the other 20 from the sodium bicarbonate times 100. So 20 divided by 620 times 100 is 3.23% sodium bicarbonate. And that's a pretty simple problem. You shouldn't have any problems plugging that into your calculator. The next practice problem says you have 1,500 grams of a bleach solution. The percent by mass of the solute sodium hypochlorite is 3.62%. How many grams of sodium hypochlorite are in the solution? This one is a little backwards to what we've done. They've given us the percent by mass. They're asking us then to calculate, if we know the percent by mass, how much of the sodium hypochlorite would be in 1,500 grams of this solution. So I'm still going to use the same formula. 3.62% has to be equal to whatever the mass of the sodium hypochlorite is over the total mass of the solution, which is 1,500 grams, times 100. And when I divide both sides by 100 to get rid of it, I end up with 0.0362 equals x over 1,500. And then I multiply both sides by 1,500 to get x by itself. And I find out that x is equal to 54.3 grams of sodium hypochlorite. So if I have 1,500 grams of a bleach solution, that's 3.26% bleach by mass, or sodium hypochlorite by mass, then this must be how many grams of sodium hypochlorite are in that solution. The third problem says, if you have 100 milliliters of a 30% aqueous solution of ethanol, what volumes of ethanol and water are in this solution? And this one doesn't really require a whole lot of math, especially since they gave us 100 as our total volume of this solution. So since it's 30% ethanol, we know 30% of 100 is 30. So there must be 30 milliliters of ethanol in this solution. And then the remaining 70%, because 100 take away 30 has to be what the water is, and that is 70. So I have 30 milliliters of ethanol and 70 milliliters of water, and that's how I make that solution. And then the last problem here says, what is the percent by volume of isopropyl alcohol in a solution that contains 24 milliliters of isopropyl alcohol in 1.1 liter of water? Well, the first thing I'm going to watch out for here is that liters and milliliters are not the same unit, and I need to make them the same unit. So 1 liter is the same as 1,000 milliliters, or if we think of the King Henry died by drinking chocolate milk, we can do a conversion from milliliters to liters. 1 to 3, because a liter is a base unit. So it would go the opposite direction as well. I'm going to go ahead and just make this into milliliters, which means I'm going to go from the base unit to milli. So it's going to be 3 places to the right. That means 1.1 liters is the same as 1,100 milliliters. And then I just plug that into the percent by volume formula. So the solute is the isopropyl alcohol, and there was 24 milliliters of that. Then I do the total volume on the bottom, which is going to be the 1,100 milliliters from the water plus the 24 from the isopropyl alcohol. Multiply it by 100, and we get 2.14%. So it's 2.14% isopropyl alcohol by volume. All right, the next one is molarity, and molarity is abbreviated with a big M. Molarity is not the same as moles, and a lot of people try to use those interchangeably. They are not the same thing. So do not mistake big M for the same thing as MOL, which is moles. They sound very similar, but they are not the same thing. So very common mistake, and you need to watch out for it. Molarity, which is big M, is one of the most common units of concentration, and we're going to use it a whole lot. Its formula is moles of solute per liter of solution. And you read big M as the word molar. So this would say a 6 molar solution of sugar will have 6 moles of sugar for every 1 liter of sugar water solution. So big mistake, Big M is not the same as MOL, but this is one of the most common types of concentration calculations you're going to have to do. So our first example problem here says, suppose you need to calculate the molarity of 100 milliliters of an aqueous solution containing 0.085 moles of dissolved potassium chloride. So what I have here written are the two steps we have to take in order to calculate the molarity. The first one is, because molarity is moles per liter, I need to change the milliliters to liters because that's the number that has to go on the bottom. So you may either slide the decimal 3 places to the left, or you could use this conversion factor and just set up a quick dimensional analysis table that there's 1,000 milliliters in a liter and do the division and you end up with 0.1. So that's the first step. Then the second step is to divide the number of moles, which they gave me, so 0.085 moles, by the liters, which I just calculated. And when I do that, I get 0.85, and it's big M. So 0.85 molar potassium bromide, or potassium chloride, I'm sorry, is the concentration of that solution. You often hear the word concentration and molarity used interchangeably. So if a question asks you to calculate the concentration, they really mean calculate the molarity of the solution. Our second question says a 100.5 milliliter intravenous solution, or an IV, contains 5.10 grams of glucose. What is the molarity of this solution? And then they tell us that the molar mass of glucose is 180 grams per mole. The molar mass of glucose, or use the molar mass of glucose to calculate the moles of C6H12O6, which is glucose. Remembering that we're trying to get moles divided by liters at the end to get molarity. So we're going to take our grams, which was 5.10 grams of glucose, and I'm going to do the molar mass to convert to moles. So 180 grams is 1 mole of glucose. And when I take 5.10 and divide by 180, I get 0.0283 moles of glucose. And then I've got to convert my milliliters to liters, so I'm going to bump the decimal 3 places to the left, and I'm going to end up with that number of liters. And then my last step is to take my moles and divide by my liters to get molarity. And when I divide those two numbers together, I get 0.282 molar. So the concentration in that IV solution is 0.282 molar glucose. All right, my practice problems. What is the molarity of a bleach solution containing 9.5 grams of sodium hypochlorite per liter of bleach? So molarity, moles per liter. I'm going to take my grams and convert them to moles. And sodium hypochlorite, if I add up all the masses on the periodic table, we get 74.45 grams per mole. So that's just from the periodic table. I do the dimensional analysis to go from grams to moles. So I divide by the grams is 1 mole, and that gives me 0.128 moles of the sodium hypochlorite. And then if I read in the problem, you're looking and saying, well, I don't see the liters, but right here it says per liter, and per liter means 1 liter. So I'm going to take my moles and divide by 1 liter, which means that my moles are also equal to my molarity. So this solution is 0.128 molar sodium hypochlorite. That's the concentration of this bleach solution. Practice problem number 2 says calculate the molarity of 1.60 liters of a solution containing 1.55 grams of dissolved potassium bromide. Well, potassium bromide, I looked up the masses on the periodic table, and it's 119 grams per mole. That's its molar mass. So again, I'm going to take the grams of the potassium bromide, and I'm going to convert it to moles. So I'm going to divide by the 119. That gives me 0.013 moles of potassium bromide. And then I'm going to divide the moles by the liters. And they've already given me liters here, so I just put that number on the bottom. And I take those two and divide them, and I end up with 0.00812 molar potassium bromide. So just making sure you have the correct units when you do the division is kind of the key thing for these. Molarity and molality. Very easy to get confused. They are not the same thing. Molarity is what we just talked about. It is not the same as molality. Molality is less common, but you do see it every once in a while. Molality is abbreviated with a little m, where molarity was the big M. This is still not the same, so little m does not equal moles, which does not equal big M. They are three different units, meaning three different things, so don't get them mixed up and don't use them interchangeably. We read little m as molal. So for example, if I had a 6m solution, we would say that's a 6 molal solution. Let's see, a solution containing 1 mole of a solute per kilogram of solvent is a 1 molal solution. And here is the part that gets everybody all screwed up. Molarity was moles of solute per liter of solution. Percent by mass was mass of solute over mass of the whole solution. The volume, the percent by volume, was liters of the solute or milliliters of the solute per the total volume of the whole solution. Each of those had solution on the bottom. Molality is the different one that has solvent on the bottom, so you need to watch out. This is only the solvent. The first problem we're going to do together says, in the lab, a student adds 4.5 grams of sodium chloride to 100 grams of water. Calculate the molality of the solution. So the first thing I'm going to do, because molality is moles of solute per kilogram of solvent, is I'm going to take my 4.5 grams of the solute, which is sodium chloride in this case, and NaCl on the periodic table is 58.45 grams per mole. And I'm going to do a one-step dimensional analysis conversion here. 58.45 grams is 1 mole. When I do that, I get 0.077 moles of sodium chloride. Then I need to convert the grams of water to kilograms. And there are 1,000 grams in a kilogram, or you can just bump the decimal 3 places back to the left. So 100 grams of water is the same as 0.1 kilograms. And then I need to divide the moles by the kilograms. So I'm going to take 0.077 moles divided by my kilograms, and I'm going to get 0.77 molal for the concentration of that solution. All right, practice problem number 1 says, what is the molality of a solution containing 10 grams of sodium sulfate dissolved in 1,000 grams of water? The first thing we're going to do is we're going to convert grams of sodium sulfate to moles. So I'm going to do my little conversion here. If I add all this up on the periodic table, I get 142 grams is 1 mole. And when I do the division, that's how many moles we get, 0.0704 moles of the sodium sulfate. And then it is 1,000 grams of water. Well, 1,000 grams of water, if I bump the decimal 3 places back, is the same as 1 kilogram. So all I have to do is take this thing and divide it by 1, and I get the same answer. And little m for the units. So there's that first practice problem's answer. And then the second practice problem says, what is the molality of a solution containing 30 grams of naphthalene dissolved in 500 grams of toluene? Well, if I add up C10H8 on the periodic table, we end up with 128 grams per mole. So again, I'm going to take the grams, but of not the toluene. I'm going to take the 30 grams of the solute and divide by its molar mass. 30 divided by 128 is 0.234 moles. And then I take 500 grams. We bump the decimal 3 places back, so we get 0.5 kilograms, which means I divide my moles by my kilograms. And my answer for this one is 0.468 molal. That's the molality of that solution. Okay, that is the end of this first podcast. So you just need to use those formulas. You'll be given the formulas on the test. You just need to be able to use them. So understanding what's the solute, what's the solvent, what's the difference between when it says solvent versus solution, and just converting between kilograms, grams, milliliters, liters, going from grams to moles, all of those things, just so you can use those formulas correctly. That's what you should be able to do at the end of this podcast.